structural engineer by trade. I lecture in structural engineering at CIT. I see familiar faces, not from the structural engineering field, but actually from the other part of what I do, which is the BIM program coordinator as part of the CPD that we offer here in Cork. Right. Okay, so just a quick overview of what I speak about. I'll look at, just give you a brief overview of what we do at undergraduate level, in particular with a structural engineering focus. Look at the research that we have ongoing, one particular project or ongoing project in particular, and look at our CPD program, just a quick note on that for those interested, and some concluding remarks. Some will feed back into what Alan mentioned earlier on. So we start in first year, and the first thing that's of importance to us is the people. Because I think the three pillars: people, process, technology. If you don't have the people, then process and technology aren't worth anything. So what we find is we get students out second level, and they're all trained to be individual, do the best in the Leaving Cert, which is a complete tunnel visioned mode of education. But that's for another day. So we got to kind of transform these people into group thinkers, team workers in the first year. So in first year, that's what we do. We set about simple projects, no big deal. For instance, 2 years ago, to coincide with Páirc Uí Chaoimh, we set a stadium design challenge, which was a very short, quick challenge. Now we've started to tie up with the movement, which is where there are no where there's no engineer, which gets students to think of solutions to problems in third world countries. It's really good in that it gets them to think about ethics, it gets them to work in teams, it gets them to think about problems that they don't know. They're kind of going, we're just come to college, how do we know the answers? And you'd be surprised the solutions that they come up with. But most important that we want them to do is get used to working with each other. Into some in first year, some in second year, we will look at the technology. So again, you can say, look, BIM is about the information. It is, but if you truly want to get the most out of it, you need to be somewhat proficient in the technology, or at least understand what the technology can do for you. So we blatantly just do 3D modeling, okay? With no mad ideas other than it will feed in when they take it on later on. What we do notice is that they can visualize what they're trying to do in the construction industry much better. Another example is using an Autodesk project, InfraWorks, where we get them to work as part of a planning module, and they get to see if you had an alternative to the Lee Tunnel. So that's representative of where the tunnel runs in Cork, and if they put in a bridge, and then they can, by seeing these things, they become more tangible for the students to understand. And me as an educator got to keep in mind, okay, I spent 12 years in practice on sites, dealing with problems, doing designs. These guys are just getting used to all this terminology, and trying to visualize it then on top of it makes it difficult. These pretty pictures, as they might be termed, are really good from an educational viewpoint. So then we move on, as I said, in second year again we do some more technology. In third year we start to kick in or build up the three pillars. In other words, the process, the people and the technology. A module under my own control is the students are charged with working for a steel contractor to design a steel frame for a particular building, with particular inherent difficulties inside in it. They have to work in collaboration with a separate floor contractor, an architect, a foundation engineer, which again, so it's like a contractor is doing a design and build and has handed out the design package for different teams, or 3 different teams, and they have to work within that. So they're starting to work and take these other models into what they're doing, so it affects how they design. So not just designing greenfield and with no constraints. They do this in groups. So again, they set up themselves up as a company that are subcontracted into this main contractor who wants to develop this building. An interesting thing that we do at the end is they write a reflection on what the process. So they're, again, almost like company leaders. They're going, okay, we got through this process. If we were to do this again, how will we get better? And they think of it in terms of people, process, and technology. So they look at all of them and say, what worked for us, what didn't. Again, that helps from an educational viewpoint, that they can learn from their mistakes. If everybody gets everything right, then I think people don't tend to learn a lot. But when you start making mistakes, as they will inevitably do when they're challenged like this, it happens. Another example is in third year, and this is an elective module that we've I've tried to eke into the course. Again, there's so much in the individual courses that can be difficult, is digital structural engineering. Fundamental to this, we'll say, let's say take 2 Georgian terrace houses, and we're retaining the facade of one of those. So we have a laser scan of that. By the way, that laser scan is not that particular building, in case you think it is. They're different. They just look alike enough for me, again, to create that idea of reality for the students. And the students, and I've shown this probably at last year's thing, take a map, they take the point cloud data, they build an as-is model of it, then they receive a third-party facade model for the curtain walling, and within that then, in context, they have to build up the proposed new structure. And when we strip everything away, we go, where's the foundation? For structural engineers, that's kind of important. So again, it helps me to go, okay, anything missing from that picture? And if they don't get it, I can explain it somewhat. The other thing it brings up is that, okay, pad footings would be the norm. If you look at that picture, perfect, a couple of pad footings there, great job. Yet if you look at it again in the context of the existing structure, you can see that the stepped out foundations of the old Georgian house have a particular problem for where your column comes down. So if you're a structural engineer with 5-10 years experience, you deal with this sort of thing day in, day out. If you're a student who's never come across it, then you can't tell me that that visual doesn't help them understand the problems that they face as engineers to design stuff. And the same would go across all the disciplines. Then we start to move into, okay, so that's using the visualization thing. Then we look at the idea of using that central information model for other purposes. We can take that across into Tekla, do some structural analysis as we see fit. And I would say on that, is that a perfect, and this is the beauty thing where we have a lot of work to do on interoperability, on how pieces of software communicate with each other, because the funny thing is when the students did do this, and it went across almost immediately, oh, this is great. What are you doing with us all this time, Ted, with that boring stuff? This is just spit it out. And then we started hitting the analysis and error, that any engineer or any architect or any QS who's ever tried to extract information, it's great when you see it in the brochure, but when you're trying to do it in reality, there are lots. So you spend a lot of time giving yourself experience of finding out what the errors are, and that all takes time. That's fine if you're a consultant and you've somebody's in charge of you that allows you to learn, because you get proficiencies and efficiencies from that in the long term. But I'm inside in a classroom with 18 students and they're getting 18 different errors. It's not exactly inclining me to push the benefits of BIM. This is the context, again, the bigger picture of what they work on. This is the common data environment. So in the common data environment, I would have made available to them the map, the point cloud, and the architects thing. So they would sit there and you can see roughly, if you've really good eyesight, that we're using the naming convention from PAS 1192. These are the two models that they've pushed up. So that allows me as a lecturer to go in, look at how the thing ties together, what they've designed. Down at a local level, they have their own company server, and they have their models. Again, we're using, let's say a company naming structure that's somewhat compliant with PAS 1192, but does reflect what people are telling me in terms of reality. And you can take that model down and create submodels. So again, they're getting this picture of how the BIM thing works. But the beauty is my module is called Steel and Timber Design. They're still very much designing steel and timber as part of the process. So then we go on to fourth year, and this is old-fashioned. I lecture, they try and listen, they fall asleep, they stay awake. But a couple of hours I give them, the great thing now, when I started doing this, they'd never heard of BIM before, whereas now they've done those modules, so they have an idea of what Ted's on about. So I start to give them the bigger picture, the fundamentals that underpin it. So I kind of show them all the other stuff, and I say, right now, let's have a proper sit down and list the standards and why they exist. And then I get them to go off and do a case study. Great thing for me here is I keep putting up the list of case studies that we do every year, so they can't use any of the previous ones. So I'm building up a whole repertoire of interesting case studies. The thing I've started to do with them now is get them to reflect back. Okay, you've got the case study. What do you think of it? You've done BIM, So I have the kind of naysayers who think it's a load of rubbish, and then I have the guys who are really into it, who think it's best thing since sliced pan, and the truth probably somewhere in between. But they go along and they, again, can tie the work inside in college to the greater scheme of things outside. And finally, probably the holy grail of what we're trying to do is the start towards interdisciplinary. So in fourth year, I have a project that I run with defining your structural engineering and architectural technologists. And I get about 15 to 20% of a module, because that's all anybody will give me to go and get architects and engineers to talk to each other. I'm sure Alan will say the same thing about, this is not an unusual thing. I know in other institutions it's the same thing. But what we do is we give them a little brief project. They have to explore the project for the early stages. And again, that putting it the early stages is because I only have a finite amount of time to work with them. Is that we look at time constraints, that's restricted. But point two there, we place emphasis on early effort, which it goes links back to the McLean curve of putting in that work earlier. So what do they produce? They produce a poster at the end which gets them thinking of all the different things. So they have some hand sketches, which I think is absolutely fundamental. They're tying those hand sketches into the BIM models. They're sharing this information in common data environment. So we have architecture students in the architectural factory, we have engineering students over in the engineering part of the building, and they again can digitally collaborate on the thing. So that's one example. Second example. So I set them in the same building. This was an event center in Doha, and I gave them a BIM model, a raw BIM model of the shape, and they had to come along then and actually develop that through the conceptual design stage. Pretty good. Gets them working together again, and works all the important aspects of it. So that's undergraduate. That's what we're trying to do. Hopefully, it's making a difference, and hopefully, we've not. I know from my own point of view, we've not compromised any of the things that Engineers Ireland want in terms of output. So if we look at the research then, an interesting research project that's kind of half accidentally happened a couple of years ago and has continued to roll, which is, any of you from Cork will know the Chetwynd Viaduct. What we did with that is we had a laser scan done by Murphy Surveys. We didn't have it done actually, sorry, it was the client, as part of a cycleway route from Cork, looking at the potential of a cycleway route from Cork to Kinsale. So they did a laser scan survey, and I saw this at a different conference. It goes, hang on, you have a laser scan point data cloud. It could be a BIM story. So what we did is we worked quite hard and we developed a Revit model of the thing. And we proved that through that we ended up with a lot of benefits. A little snapshot of the benefits is here on the left, in terms of the whole screen actually, is looking inside Revit. Here is the 3D model. Here's a particular fractured element of a tie rod. So at point 1 you have the tie rod. I can select that, the properties will pop. Within the properties box, number 3 will tell me the type of material. At number 4, there's a photograph linked in. So you can see the photograph of the real Chetwynd Viaduct and the model. And there, again, as a senior engineer, you don't need to, you might have somebody who's more junior, goes out on site and does all this stuff, and comes back and say, look, here are the key points. That engineer can now get a sense of what's really the problem out there and where it exists in terms of the entire project. And finally, they can put in as well, you can register what type of condition that's in. So from an asset management, this would be typical in bridge maintenance contracts, that you would be scoring it. And again, you can create automatic schedules and all that from that, so you can see how many issues or serious issues are contained within a particular bridge structure. So that was the first element. We moved that on then, and a student in the last year and a half took it on as part of a research project, final year in our structural engineering degree, to see if there were further benefits. So I'd taken it up to an as-is model, and I thought, yeah, there are benefits. Let's see what happens after that. So he looked at 3 different strands. He looked at the technical aspects of assessing the existing structure, design development with the new elements for the proposed cycleway, and finally how it operated in terms of communication. And taking the first one, first of all, in terms of the model, he was able to take the Revit model that I had developed, bring it out, that's the analytical model that sits behind it, and bring that out into structural analysis software quite quickly and run the analysis. Now, of course, that wasn't perfect, but over here are some of the outcomes. So quickly, in the non-BIM approach, you need separate analysis models versus your element model as such. So that takes time. That was negated by the fact that I built one model that now is being suited for 2 purposes. There were interoperability issues. There they are again, this interoperability issue in terms of the material properties weren't right, so they had to do a little bit of work in the analysis software to feed it back into the robot model properly. And finally, the analysis results were comparable with the original assessment that was done, the traditional approach. The thing to point out, I found it really difficult. There was in the long run of the bridge, there's a slight bow in the spandrel wall, and if anything's bowing, it's more likely to buckle. Unfortunately, Revit, and if there's somebody in this room who can help me with this, I was able to adjust it in 2 directions, but that third direction, Revit really doesn't like being slightly out of plane. So again, I'm pointing the beauties of technology, but I'm hopefully giving you a dose of the realities that exist as well. So there are limitations that we need to get through. Second part is design development, and again, he was able to go along and look at the new proposed elements again and use interoperability to solve that very quickly. And do analysis again to the current codes, which is brilliant. And finally, we could look at construction sequencing of the bridge look at clash or gap analysis in terms of between the existing structure and the new structure. So again, all of those would have to be independently created, whereas all this was like a byproduct of that original as-is model, which, by the way, took longer to create than, let's say, the drawing and the solid model that was created at the time. But now we're looking at the long-term benefits of those. Finally, communication of design and thinking. I think this is really important. I've alluded to it on many occasions. And I know Alan said collaboration. I think this idea of communication is almost the fundamental. Either it's you talking to the next person, or it's the computer program of one talking to another computer program. That communication is vital. That's typical of what you put up in a public consultation. Look, this is what we're going to do, everybody. This is how it's going to look. And people who are typically non-AEC sectors will be going around trying to interpret 2D drawings, and they might again not be their thing. Whereas with the 3D, we are able to spit these out. There's an old photograph of the deck when it existed, and we were trying to replicate the flat iron bar coming up and rather than having the wire running along, and we were putting in glass from a safety viewpoint. But we were trying to replicate. But it was giving us this opportunity to tease that out. Again, much easier than it would have been had we just used had we been doing the traditional approach. So we set up a little experiment to see, does the traditional approach, where we have two kind of 2D drawings with a couple of photographs, maybe a couple of photo montages, how does that compare with, let's say, we had some we had some video running of a fly-through of the thing. We had VR, so you could pop the thing in the head and have a look around and see what it was. And we got a couple of hundred people, or at least over 100 people in CIT on any particular day. Some were from AEC, some were non-AEC discipline, come in and say, what did you think of it all? And by far and away, the visuals that were created via the BIM approach was much more significant in communicating what was the intention, okay? And that's vital. We only have to look at flood defences in Cork to see how vital it is to communicate with the non-technical people, okay? It's highly controversial, and I know who gets shot for that particular approach. The engineers, which I think is completely wrong, because they were set, look, this is our budget, you got to get the city being flooded for the minimum price, absolutely fine, but then you run into potential communication issues, and this can be a huge resource for us on that front. So again, that worked, and that probably is no rocket science there, that if you show something more immersive, it can be a huge benefit. Somehow I've gone back to the start. You don't hear all that again, no? I don't want to say it again. I'm already down for too long. So the last section, which is on the CPD, is very brief, just for those who weren't. The last point to make on that is, and this is important, just last Friday night, that particular project by Nick Bailey won the Institute of Structural Engineers Ireland Top Student Prize. Now, why is that important? Because the Institute of Structural Engineers, just like Engineers Ireland, BIM is in the background, okay? It's certainly not forerunner. It certainly wouldn't be the type of project. I said to the student when he was taking this on, this won't win you any prizes because it's about pretty pictures, okay? The thing is that, you know, a neutral panel and sat down with master students from DIT, from Trinity, from UCD, and with students from DIT and from UCC, and said this won it. This is important not from my students or for us. It's important from the point of view of actually the recognition that now gives BIM, because we're moving past this thing of, you know, it's not just the pretty pictures. And I think one of the judges at the time of the presentation, you know, who's going to pay for all this BIM was the question that came out of the judge when Nick was speaking. And again, that was somebody coming from zero, I think, understanding of what BIM is all about, okay? Hopefully, and obviously Nick must have worked some bit of magic, because, as I say, it won the prize, which is important from the whole BIM perspective, that it's getting recognition at that sort of level. In terms of CPD programme, most in the room, some of the room already know about it, some of it have sat through the pain of it. So it's three modules, 15 credits, special purpose award. I keep saying I'm going to come back to you and say there's going to be the add-on, the build-on. It will happen, it's just a matter of time, but very soon it will happen. But it's kind of unique in probably, as are most of these programs across the country. It's not for engineers, it's not for architects, it's not for MEP, it's not for quantity surveyors, it's actually for everybody. It's for all of those and above, which can prove challenging, okay, to try and satisfy all of those, but we've tried to create that. The feedback is generally good. I haven't quoted anybody in the room, have I? Fiona? Feedback is generally good. Very good. In particular, the fact that it's the multidisciplinary aspect and whatever. What I will put up there is the downside of it. So obviously, I won't write that one down. The downside, people have come back to me. It's really challenging because it's over 14, 15 weeks. It's Tuesday evenings and Friday afternoons, and it's tough going from there to Christmas. From September to Christmas, it runs. It's difficult because everybody now is working full time under an awful lot of pressure if you're working on BIM jobs. So keeping that thing happy, that side of it going as well. So, but the other thing is positive. It fits into 15 weeks, and you are a walk away. Now the downside for me, and it goes back to I'll allude back to what Alan might have mentioned earlier on in terms of I've done a bit of cost analysis. People ask me, and is it certified? Will I be BRE certified or something like that? And I'm going no, okay, which is unfortunate because I've added up. If you do 3-day technology courses, which are typical around the place, they're around 500 plus that. So if you do 3 of those to cover Revit Structure, Revit Architecture, and Revit MEP or Navisworks, they would be typical. We cover all of those. That's 500 multiplied by 4. If you were doing the BIM level 2, which is 2 courses, you can get an online special of €508. I have done that. Anything that's on that is in the notes that I deliver within our own one. Okay. Total there is 4 number kind of technology courses plus the theory side comes up to 2,508 plus that. So €22 plus that per hour of your contact. In CIT, you have your introductory module, which is about 30 hours of just Revit without the BIM stuff. And then we start to move into the more discipline-specific stuff, and finally the theory and practice. All that's €1,500, $11.90 an hour. I'm not putting up that because in fairness, we've had really every year on year really good attendance, good participation. It runs really well. I'm not putting it up there to say how great we are. My problem is coming back to an issue that exists, which is that I can't say to people, yeah, you're BRE certified or you're the equivalent to that, and that's what's making the headlines right now. So to hear you, Alan, going on about NSI coming in and becoming that, and then working with us so that our courses, across all the institutes, tick the box, because it's kind of it jars with me that people are coming over from the UK in here and accrediting us for a UK qualification, and the money's just, this is like, we should be like supporting our own. This is the one thing I think I stood here in this very forum about 3 or 4 years ago. I said the one thing I was delighted about BIM is that we could export without exporting our people. I've seen friends in the last 10 years who left, and now I see people working on jobs in the Middle East and further afield and in Scotland or whatever, and this is great because they're still here. And this is the thing I liked. What I don't like now is this, like we're almost looking outside to, will you approve us? I think we need to get that inside approval so that I can say to someone, yes, you know what, you are going to get approval. It is recognised, other than, I think, the value for money that you get from it. So in conclusion, so we've progressed the undergraduate as best we can. It makes no difference to you guys. You're all out and doing fantastic things already. But hopefully it tells you the story of what we're trying to change. And what I always do is I meet people at these things, tell me what you think should happen, okay? And people have no experience to loads of experience come back and go. And it's these little tablets of information that I use when I'm redesigning stuff that I do at undergrad level. And indeed the same in terms of the CPD program. It's that link with you guys that helps me. And I'm always open to queries, comments, collaborations, whatever it is. Just drop me an email in CIT, or you'll find me somewhere on Ted McKenna. Okay? Thanks very much.